I'll wait for somebody to pop in before I start chatting up. I'll start talking. The volume works, guys, if somebody's waiting for me. Oh, that was interesting. Hey, go by first. Say hello, anybody. I know who you are, or if you want to comment, you don't have to, but I can hear the people going by. So look, if you Google this real quick, you'll get the Reedy Chesapeake Bridge, Reedy Point Bridge. It's Army Corps of Engineers Bridge. They're the ones that maintain it, so this is not a state bridge. This is a not a city bridge, but hey Tony, thank you for saying hi. Control joints are one of the first things I look at. Expansion joints, rather. My brain's about not working today. This is an interesting span. There's your mid span, right? It's covering. I'm gonna back away from it, but let's just back away and see if I can give you an idea of what we're looking at. Hey Hermit, you're over here now. Hermit, this is the rest of that bridge. You were just finding data on it. It's the Reedy Point Bridge underneath. Was it Reedy Point? G-R-E-E-D-Y Point Bridge? I think that was it, Hermit. I titled it Reedy Point. Shoot, I gotta go in there and retitle the bridge. Reedy Point. When I couldn't find it. R-E-E-D-Y. Reedy Point. I'm thinking about myself when I'm hungry. Reedy Point Bridge. Please, can you comment down there and correct that for anybody who might want to look at it? R-E-E-D-Y, Reedy Point. Come on, camera. So much for the zoom now. I'm going to need that. Reedy Point Road. So it's Reedy Point Bridge. It's interesting. They go from girders, one system to another girder system. But we're back to a truss system. Scale, the massiveness is beautiful. This goes from this, guys, as you watch it, and it gets bigger and even larger to that point. And then she scales down and she rolls across in the mid-span and does a mirroring system on the other side. I'm in love with expansion joints on bridges. I find them the most, gotta watch somebody rolling by in their truck. Make sure to keep rolling by, and it's the way I think, guys. I got a pole right here next to me. So anybody want to get stupid and try to run you over, they got to hit the pole at the same time. And I don't underestimate people. So that's who I am. All right, Reedy Point opened 1968. Thank you. So now we have a bridge, and this is the bridge related to, well, if we think about the Genoa Bridge, it's about the same time period. Here's a steel structure. Now let's base this on, that's why I've picked this one today, a steel structure with the same timeline as the Genoa Bridge. The traffic may not be the same, but steel, baby. Steel is the way to go. Now let's get to these expansion joints, which I'm in love with. Expansion joints, different styles. Right there in the middle top, guys, right here above my finger, that's this one. And then looking down, that's the other version of it, adding the flexibility for this as it transfers the loads down to here. This is where one of your movements that you could have really addressed, making sure they can't fail, of course, but it is not mirrored on the other end. Built by the U.S. car, that's right, and they still own this son of a gun. So they own it, it's their bridge. Okay, hello, I just did a flip screen, flipped image. I'll do, I flip it back. So that's what my face looks like right up out of nowhere. I didn't mean to scare anybody. I didn't mean to scare you guys. I was going to get my drone out and take a shot of that real close, but heck. This is a box truss system, so that each one individually, imagine like a box truss. It's not an I-beam girdered system. It's 4 plates, and two of the plates have holes in them, and the other side of the plates are solid. It's a riveted system. There's the truss plates, the nodes, top and bottom. But at this point, this is how they address it. They allow the flexibility to happen on this node and this connection here and here. I don't want to give anyone ideas, but you can imagine that would cause the failure of the bridge right there if you take that joint out. It's all got to work its way through these joints. Wow, you gave us the finger. Yeah, Rick, I guess I'm treating you guys bad now. My fault. But again, the slenderness factor is not here. This is not the FIU bridge where they said we can make a bridge the same all the way across. That craziness with concrete. But look at this thing again. I'm going to go out and I'm going to taper off. My hands are going to get closer together. My fingers are, to show that the slenderness factor. Beautiful how they stepped that up and gave it the extra height there to take all the loads of the structure. Half of it there and half down that little lady side. Again, I didn't see the expansion joint on the other side. Oh, yeah. I take that back. So edit the video. Delete that. Delete that. And let's reject that phone call. So there is the other expansion. I thought I found something that was very unique. Expansion on one side, but no, I see it down there now. It's there. And it has symmetry. In other words, it's the same distance in as over here, allowing it both sides. I was like, wow, this thing is expansion on one side, which would have been pretty unique. Built for purpose. Now, again, there we have a different the truss system going over. When you look this up, is it Warren truss or is it or they call it a Pratt system? I know the answer. I'm just letting you guys enjoy it. And so back to this one. There's something you said, perch, remind me, Hermit, of what I should have addressed. It says an arched top and a flat bottom. I started making a video and I was going to load it later, but then I got signal so I can go live and show you guys live, which you guys like communicating to each other and things like that. So it looks delicately perched. That's an interesting thought. You could even, if wind loads could get it, you'd only have to rock it a little bit, right? That's an interesting thought. We got all these years of all the wind not doing anything about it. That's arched. The top of it's arched, guys. Arched. As you can see here. And then she starts leveling off right about there somewhere. And you can see it even playing with the deck. And then you see again now we have the girdering system, truss system on this last section before it goes over to girders with floor pans, and then it goes down to just girders only. That was in the previous video on my other channel. I just showed that. If you look at my other channel, Hermit was over there. What are these? What are these, guys? What are these? Hold on. What are these things in the water? What are these things here? Each an electric pole going out to each one, and then a pole's in the ground, but it's all the way down there. If you go across the, I guess you would call this the canal, the river, you'll find them over there also. Give me a second to see if I can orient myself. You find them parallel to those. Kind of tough for me to get you guys oriented there with this camera. Yeah, that's a thought to share with you. Give me a second. I'm looking with my eyes now and not that. Nope, I'm not going to be able to see them with this camera. I'll have to be further down there to show you. But what are these poles in the ground? Look at them. And this electric goes to them. Let's see what your answers are. Boats. Yeah, Hermit doesn't say what type on Wikipedia. Cool. So they're light poles. Look, there's a light on each one of these poles. 220 volts. All the way down. And it's on the other side also, all the way down. This canal is so important. They light this thing at nighttime. They light both sides of the canal all the way down to this other bridge. And I think this other bridge might be what they call the Summit Bridge. Orientation might be off, but maybe you guys see it on Google. That's another structure that's interesting. But I wanted to bring you to this one. 1968, baby. About the same as your Genoa bridge. And you don't see it falling on the ground. Steel. Steel. You want to build a bridge, build it of steel. Not that bullshit ship canal. That's right. You don't build that bullshit post-tension concrete stressed concrete. That's just ridiculous stuff, guys. That's ridiculous. I don't know how this is not considered the acceptable norm only. In fact, I think I will look at some Corps of Engineers studies. Herman might beat me to it, to see if you guys might beat me to it, to see if they have done any post-tension bridges now since 1968, or do they cough up the money still and still do it in concrete? I mean, steel. I'm trying to make the motion show. Or look behind it, guys. I'm gonna back up a little bit. We got a jet ski rolling up on his ass. Come on, catch up. Oh, he's jumping his way. Another jet ski behind that one. We're gonna play a little. Another jet ski behind that one. They're jumping the guy's way. Got another. Then you guys just got a regular boat behind this one. Interesting little setup. That's just kind of cool to watch, right? I thought that guy was going to wipe out. I guess that jet ski held on there. So there's your system. There's your transfer load. So it's multiple things. What happens here is the load is transferring in this last box beam, is the way I look at it. Coming onto this system here. It's tied in transferring its load back to the. Let's see if we get this. Let me get my finger. Coming down here, going back up here and back down here. Not too much going on up the top there. So this design is designed pretty much, if I get this suspension joint right, is transferring the load down here and back up to the other side. And this is just going to act as your expansion moor cell. I can't get closer to it, but that's how I see this setup. Very interesting. Let me get you a little zoom in on that. And that becomes, so I have to amend part of my statement, that becomes more like an I box beam. Check it out. The outside flanges of it. See how it sticks out further? It's not really squared off. Come on. That one to the right, center one going vertical, and then the other one's more boxed. That's more like an I one, and that's the joint that I'm in love with. All expansion joints I'm in love with, especially the ones on time like this, 1968. There it is in practice. First it was in theory, and then there we have it in practice. That's about it on this video. I wanted to share that, and I guess the joint was more what I'm sharing, but I guess I can show you the underside. Talk about why I love structural pans, P-A-N-S. Said it on the other video as opposed to anything else. This is a kind of different also though. Let's go to the side, trying to get the lighting right for you. So on this side, let's look at the bridge deck, how it transfers the loads down, this load path. It's coming, yeah, beautiful. We got these braces coming across, these girders coming across from here to here, the sides. See if I can get a little better one there. I can't get the lighting any different. Coming across, transferring the load down. Let me get over here. See if I can get a better lighting. It's well, maybe it does have better lighting. My camera seems pretty, my lens, my side looking at it seems pretty damn dark. So this is a bracing, lateral bracing. Camera froze up. No, you're looking at me again. Hello. Do that again. The camera rotation's on the bottom. I keep covering when I'm holding the camera. Let's see if I can zoom in. This is getting to be boring. this girder. Guy must owe me money. He's tracking me down. So there's the girder here. I'm going under the structure. I'm going under the, we're going to show you the bridge deck, how it transfers the load down onto this girder system. And it's massive, guys, massive. I think we might do a little better shot here. And looking. Girder across. Catwalks down the middle. This cross bracing, disregard it. This bracing here holds these stringers. These long stringers going across. Then it hits another one. Another girder transferring the loads. The stringers. Then it hits another girder coming across. Transferring the load downwards. Always in these uprights do they transfer the loads from the girders down in the uprights. Transferring it to a joint. The jerk. Camera jerk. Each girder is transferring through an upright, a vertical. Not a diagonal, a vertical. And it's transferring to a joint, which you want loads on joints. Not in the center, not the center of these guys. You wouldn't want loads there because that's where you're going to cause failure. So let's see if this happens better. And hello again. Hello again. Here we go. So all the girders coming across, taking the stringers. I can't hear, and is that one better? Zoom in, damn it. Lighting is I have no idea why the lighting's not beefed up. I'm trying to move the camera around so finally we get the camera tricked out on lighting. It just refuses to catch this lighting properly. Changing my focal point to the darker side of it, and it's still beating my ass. I'm trying to find a focus point, guys. We'll take this one. The girder's going across. What you see here is mirrored from the other side. It's transferring into this upright, not at the joint up top, but in the midsection, well, a section of it, transferring down to a joint. Whoa, 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 whoa. There can't be a girder there then. That's not a joint. This is not a joint like these. That is load bearing. This one is load bearing from here to here. The bridge deck is taking load onto this mid-span, not at a joint. Mid-span, not at a joint. See the girder coming across here. I don't know if you guys can see it. Trust me, it's there. That's taking part of the floor beams. The stringers transferring the load down here, not at the joint, but maybe they would consider that oh, it's got cross bracing on at that point. Interesting. So this cross bracing it's just cross bracing. It's hollow. I'm not gonna. Looks like H beam. That's a very interesting setup here. It's like an H beam system transferring to each side, also laterally bracing everything, but the butt part is that's load bearing here. If it's on this connection here, it's pulling down on this one. It's also pushing down too, but it's pulling down, putting a load back in the joint. I mean, this is really functional in real life all these years later, with 50 years later. So you can say that that system would still work, that you can do something like that. I don't see any deflection in here. There is no deflection. And oddly, that joint even sucks ass right here. think it would be non-load bearing, this joint, pretty much. Well, not, you know, not this typical load bearing down these diagonals. See the only couple of rivets, no deflection. So right there, how's it anchored in? That would be interesting, how it ties into this tie, the floor beam, floor beam, and that is pulling down, also pushing down. That one that looks okay here. Oh, it does. All right, thanks, Hermit. Like me, I'm looking at a dark screen pretty much, and I'm trying to compensate it when I'm talking to you. That one's for my record there. I'm looking at the rest of the setup, guys. Yeah, and they do it consistently. The spacing seems to be consistent, and it doesn't have to fall in a joint. They've got load here, pulling down, yeah, but it's also there. It's also there at the same time. But they also have a cross bracing, which puts it over there. This bracing coming from, this is the one that I find interesting now. Coming over to here, which means the load coming down, also go this way, and also pulling down, also pushing down. So pulling, pushing, and compressing that way also downwards. Huh. All works. All works. It all works. I'm looking at it. I'd love to see how this connection is here on there, how it's actually tied into it. Even zoomed in, I can't quite. I'm walking on it again. Show you what I'm doing. Okay, maybe I'll zoom in and you guys can see it. Hermit, you tell me if you can see that. That's the one that's pulling, so you can see it goes into the mid. Don't get confused with these members here. They're cross bracing. They're not these big guys here. It's a cross bracing going across. So looking back at that joint in the center of the video at this point, it's like a little bracket tied into the diagonal, the vertical, and that floor beam it's okay, Herman. No, I was just saying, if you see a plate then. A plate, since you can visually see, is what I wonder if you could visually see, if it's too dark, the image. And I'm showing you guys a blank screen, which would be stupid, right? That's what I was really talking about. That one's very interesting. I'm gonna move on from it. I'll put it in my yes you can do that folder. Yes you can do that, based on 1968. 23 minutes, 19 seconds. I'm hanging up. I'm gonna break out my drone. I'm gonna get me some good close-ups of that, and maybe even run that joint real quick. You guys can't see the drone video live, and you can see the canal before I go. I see corner plate with 2 bolts. Well, they would probably be, I don't know if they're not interesting. Probably rivets, 1968. All right, going to disconnect, and I'll see you guys on the next one.